Warning: in most real-life situations, conservation of energy does not exist because there are outside forces. We can still calculate things in these situations, and we'll show you how. Conservation of energy means that there will be the same amount of energy at the beginning of a problem as there is at the end. For this roller coaster, this means at the very top there is only potential energy, and at the 0 point at the bottom there is only kinetic energy, and these two energies are the same. In order to find certain things in these equations, you can set the energy initial equal to the energy final. You then would write out each kind of energy you have initially and each kind of energy you have at the end. This would be potential energy due to springs at the beginning, potential energy due to gravity at the beginning, and kinetic energy, equaling potential energy due to gravity at the end, potential energy due to the springs at the end, and kinetic energy at the end. In this case, we only have potential energy due to gravity at the beginning and kinetic energy at the end, so we set these two things equal to each other. We then plug in the values of these, which potential energy would be mgh and kinetic energy is 1/2 mv squared. Since both sides have mass, we cross those two things out and then plug in the height value and solve for velocity. If we did assume that we have friction or air resistance, we could plug this in for work in our equation, so it would be EI equals EF plus W, and then we would carry the W all the way through and solve at the end for velocity. Energy can also be added to a system, such as a rocket taking off and the engine adding kinetic energy to the system.
Energy can also be transferred from one form to another, such as gravitational potential energy turning into kinetic energy. In this example here, a human is falling from the sky, and his gravitational energy is being transferred to kinetic energy as he speeds up towards the Earth.
In momentum problems, energy is not conserved in inelastic equations, such as two people running into each other and sticking together.
In another example of energy-changing forms, a pendulum swings back and forth. At each end, the gravitational potential energy is at its maximum. When the pendulum is at its lowest point in the middle, it has the highest amount of kinetic energy. This is because the gravitational potential energy has been changed into kinetic.
At the point where the person jumps off of the pendulum, all of the energy turns into horizontal velocity, and the person's horizontal velocity stays constant. Now let's explore some more examples of where energy is conserved, hilariously.